Welcome back to Brushing Up on Algebra. This video is going to be about rewriting fractions with negative exponents and expanding fractions. A long title for what's probably going to be a pretty short video. This isn't something that's usually explicitly covered in an algebra class. It is talked about, just not in this way. This is sort of a different way of approaching something that you really already know. And it's used fairly frequently in a calc class, so I thought I'd go ahead and cover it here. Now, from the basic rule of exponents, we know that a over b, when we have a over b, well, that's the same thing as a times b to the negative 1. You just take the b and you move it to the numerator. That's really sloppy. And then you have a negative exponent. So, for example, if you have x plus 1, I don't know why I did parentheses, x plus 1 over x minus 2, well, that'll be the same thing as x plus 1 times x minus 2 to the negative 1. So that's pretty simple. That's just a matter of taking that, just rewriting the fraction using that negative exponent. And let's go on to another example. This is only slightly different. When you have x to the 5th over x plus 7th to the 4th. Well, that's going to be the same thing as x to the 5th times x plus 7 to the negative 4. I just changed that exponent to a negative. That's doesn't look much like an exponent there, does it? That's still not much better, but it doesn't matter. You know what I mean. So I just took that exponent and made it a negative and brought it to the numerator. Now, this is what we're really going to be using quite a bit more, though. We want to be able to separate fractions using this rule. And as you can imagine, this is called expanding a fraction, because you're taking one fraction and making it into multiple fractions. And an example, look at example 3. If we have x plus 3 over x, well, this will be the same thing as x over x plus 3 over x. Well, this x over x, that's the same thing as 1. And 3 over x, that's the same thing as 3 times x to the negative 1. So this is the expanded form of this fraction. Now, depending on exactly what you're looking for, you may want to keep this as 3 over x, but in calc classes in particular, you're going to want to keep this as x to the negative 1. Whenever you do what's called taking a derivative or taking an antiderivative, keeping it in this form that I have here is easier to use. Okay, now I'm going to go ahead and just say don't make this mistake. When you have 7 over x plus 3, don't make the mistake of saying this is 7 over x plus 7 over 3. This is not correct. I'm going to head and write no there. And the reason why it's not correct is because of this denominator right here. You want to make that denominator, you can only separate them when the addition is in the numerator, not the denominator. So this doesn't work this way. This actually cannot be expanded any further. You can rewrite it as 7 times x plus 3 to the negative 1, but you can't expand it. This is as expanded as it gets. And now one last example. When you have 2x squared minus 3x plus 8 all over x squared, this will be the same thing as 2x squared over x squared minus 3x over x squared plus 8 over x squared. And going down here, these x squareds are going to cancel. You'll have just 2 left. This x is going to cancel with one of these two x's, so you'll have just 3 over x. Nothing cancels over here. And now I want to go ahead and rewrite this using negative exponents instead of fractions. So 2 minus 3x to the negative 1 plus 8x to the negative 2. And this is the expanded form. And again, one of the earlier things you'll be doing in a calc class is what's called taking a derivative. And although you might not know what that is yet, taking the derivative of this is a whole lot easier than taking the derivative of this. And that's why we expand these out. That concludes this video. It's pretty simple. I'll see you in the next one.